A quadratic function is any function where the highest power of x, or whatever the variable might be, in this case x, is squared. The highest power is x squared. And it can be written in this particular format here, which is called a completed to square form. The reason this is of use is if I put in a value of 4 in here for x, I'm minimizing the value of this whole function, because when 4 goes in here, this whole function here on the left hand side, x minus 4, becomes 0. So it's the only value that will make this 0 is x equals 4. So the minimum value of this function will be when x is equal to 4, and then I'm going to get y is equal to 7. Because when x is 4, this whole thing becomes 0 to be squared, which is 0, and y is equal to 7. So the minimum value of this function would be 4, 7. So this particular function would probably look something like this. So 4, 7 is over here somewhere, and that'd be the minimum value. So we identify our minimum point immediately just by drawing it like that. So how do we create a quadratic function in this particular form? Okay, well, we start off by putting our x, and what I do is I half this b value here. So it's going to give me minus 2, and I square that. Now let's look at this. So I'm going to have an x minus 2 multiplied by x minus 2. Well, x by x is going to give me x squared, minus 2 by x is going to give me minus 2x, and then x by minus 2 is going to give me minus 2x as well. So that gives me my minus 4x. Unfortunately, I am left with a minus 2 by minus 2, which gives me plus 4. So I need to get rid of that. So minus 4, and then I put down my original plus 7. So this equation here I've just done is now exactly the same as this one. It's written in a different format, but it's the same function. And then I'm going to now go x minus 2 to be squared plus 3. So that's my function written in completed to square form. And the minimum point on this particular function is equal to 2, 3. Because if I put 2 into this function, this side becomes 0. I didn't mean to do that in blue, but it becomes a 0, and then I'm left with 3 on this side. Okay, let's look at another example. Okay, very similar. I want to get it in x squared form, but I have this 2 on the outside. So what I do is I just factor out the 2 out of everything. X squared plus, that's going to be 9 over 2x plus 3 over 2. So I just take the 2 out. And now I proceed like I did last time. I leave my 2 here, and I'm going to go x inside a bracket plus, now 9 over 2 divided by 2 is 9 over 4. That's going to be squared. So 9 over 4 squared. Now when I square 9 over 4, I'm going to get 81 over 16. So that's going to be added on. So I need to take away 81 over 16. And then I have my original 3 over 2. All of that is multiplied by 2. So that's 2 times x plus 9 over 4 to be squared minus 81 over 16 plus 3 over 2 is equal to minus 57 over 16. They were just sound effects to make it sound like I did that in my head. I have a calculator beside me. So minus 57 over 16, and it's still all multiplied by 2. Now I can expand out, multiply it by the 2 again, and that's going to give me, and I'll do it in red to make it stand out, 2 times x plus 9 over 4 to be squared minus 114 over 16. And you can clean that up any way you see fit. Okay, so now what's the minimum point, or the turning point they're also called, on this function? Well, it's still minimized when x is equal to minus 9 over 4. This thing here will still be minimized when x is equal to minus 9 over 4. So therefore the turning point on this, I'll maybe use blue now, is going to be minus 9 over 4, comma, minus 114 over 16. I didn't pick easy ones, did I? So that's the minimum point on this particular function. It does have maximum points as well, but for maximum points, you're going to find out how it's going to have minus x squared quadratics. Okay, and lastly, we'll try one more of these. Now, in the same way, now we have a minus x squared. So this particular function looks like this. All right, so it has a maximum point. But so what I did is, in order to complete the square, I need to get inside out, just want to get an x squared. So I'm going to leave my minus out here. That's going to be x squared minus 4x plus 10. And then I proceed exactly as I did the last time. And the minus, I can bring it back in later on if I like, but that's going to give me minus square bracket x minus 2 to be squared minus 4 plus 10. That's going to give me minus x minus 2 to be squared plus 6. And that's going to give me, now let's now get rid of the big brackets, minus x minus 2 to be squared minus 6. Okay. Now before I draw it, I'm going to think about it too. You should visualize, try to work out where this is going to be. What is the minimum point? Why is it, what's the maximum point, should I say? And so on. Try to get your head around it before you just... And by the way, use Desmos or some other graphing tool to have a look as well. It's always a useful thing to visualize what it looks like. So the maximum point, or the turning point, is 2 minus 6. What else can you say about the completing the square, which is really cool? If you let it equal to 0, okay, when the function is equal to 0, you're going to get the roots. So for example, if I let this function here, okay, minus x squared plus 4x minus 10 equal to 0, I'm finding out when is the function, when is y equal to 0. In other words, what I'm finding out is when does it cross the x-axis. So if you let it equal to 0, and it's a lovely thing to do with the completing the square format. It lends itself to doing that very easily as well. So let's have a look at some of those examples. If I let this first one equal to 0, I'm going to get x minus 2 to be squared minus 3 is equal to 0. That means x minus 2 to be squared is equal to 3. And that means x minus 2 is equal to the square root of 3. Not forgetting plus or minus. And that means x is equal to 2 plus or minus the square root of 3. Very cool way to get the roots, isn't it? Rather than the minus b formula or something. Nice. Let's try another one. So we're going to get x plus 5, sorry about the writing, to be squared plus 8 equals 0. X plus 5 to be squared is equal to minus 8. And x plus 5 is equal to plus or minus square root of 8. If you don't know the plus or minus, you can ask. I'm going to assume you do know. And x is equal to minus 5 plus or minus square root of 8. Okay. And now let's have a look at the last one. That looks the trickiest in the one with no space. Of course, I should have a squared on it. I forgot about that. So I'm going to get minus x minus 2 to be squared plus 5 is equal to 0. So that's equal to minus 5. I can multiply both sides by minus 1 because it's an equation. X minus 2 to be squared is equal to 5. And then I continue on as before. Okay, I'm going to do this last one on the next page in a bit of detail, just maybe a slight variation of it. Okay, so we have f of x is equal to minus x minus 2 to be squared minus 5, and this is the actual function here. And we're asked to find the root, so where does it cross the x-axis? And as you can see, here's the function, minus x minus 2 to be squared minus 5. It doesn't actually cross the x-axis, so let's have a look and see how this actually works out. So I'm going to continue on here. I'm going to go so to find the root, I'll let it equal to 0. So minus x minus 2 to be squared minus 5 is equal to 0. That means minus x minus 2 to be squared is equal to plus 5. I want to get a plus on this side, so I'm going to make it x minus 2 to be squared is equal to minus 5. And x minus 2 is equal to plus or minus the square root of minus 5, and we're into complex number territory here, and x is equal to 2 plus or minus the square root of minus 5. When you see a root that has a square root of minus number, you know that it doesn't have a real root. It has complex roots. The maximum point still is equal to 2, this here, you can read that it's still equal to 2 minus 5 is still the turning point, 2 minus 5. Okay, that's completing the square, that part of functions. I'll do another few of these and hope that one helps. Okay, if you've got any problems, let me know. Thank you.